Hello, good morning, good afternoon, and good evening. I'm very excited to welcome all of you to this very special webinar on a very special subject, Zero Liquid Discharge, together with our expert, Christos and Marco.
You.
So
Hello.
Before we begin, I would like to introduce our speakers quickly, and then we move on to the subject. So Mr. Christos Charisiadis is Brine Innovation Manager from a prestigious engineering firm, and today he's representing us as an independent specialist. Christos is usually focused on zero liquid discharge and brine mining. He researches, develops sustainable solutions, and collaborates with partners for a greener future. He's passionate about environmental conservation, and he leads projects and explores wastewater technology, aiming to advance sustainability. Welcome, Christos.
Okay. Thank
Then
you.
we have Thank you. Then we have Dr. Marco Van Beek. He's the Technical Director for KLAREN Technology in Taprogge GmbH. He oversees technology development and project management while contributing to sales and growth strategies alongside the business development team. His career began with a focus on process equipment for power plants, evolving into industrial maintenance. And in recent years, he has been focused on developing and upgrading this self-cleaning technology for heat exchanger, aiming to achieve up to zero fouling operations. And myself, I'm Amol Palve. I'm sales manager for KLAREN Technology in Taprogge GmbH, and contributing to global sales strategy and brand awareness for the KLAREN Technology together with Taprogge's infrastructure. So before we begin, just a little bit practicalities. As some of you can see these windows, and depending on number of screen, you can hide the menu with the orange arrow. By default, all of you on mute, and you can chat with us, ask your questions in the question and answer section. And we would also like to hear your voice through polls that we are going to put throughout the session today. And of course, the recording will be shared to all the participants after the session. And there are two files in the download section. One of them is also today's presentation in case you would like to refer it again. So some of you might be joining us first time. I would take one and a half minutes to explain a little bit about our company and the brand. Taprogge GmbH is a family-owned German company. We are a global clean tech specialist active in industry for more than 60 years. Taprogge has various technologies and active in different industries through those brands. And with the technologies, we are also contributing to the greener future with the sustainable solution. KLAREN Technology is a competence brand of Taprogge GmbH, which offers continuous cleaning solutions for either new or existing vertical shell and tube heat exchanger. We design, engineer, manufacture, deliver, and commission this self-cleaning fluidized bed heat exchanger that you are going to learn more about the products and how technology works in the session 2. And this technology can be applied in all the industries where vertical or shell and tube heat exchanger is applicable, where you could achieve up to zero fouling operations. Some of our products are self-cleaning heater, cooler, evaporator, crystallizer, and reboiler. And today's session is mainly focused on evaporator area and how our self-cleaning evaporator innovative product can help you to achieve better operation in zero liquid discharge systems as well. So we are active worldwide. You can see the global presence with the blue highlights, and the black dots are nothing but our offices. As we mentioned, head offices in Germany, Wetter, and the KLAREN Technology Competence Center is in Barneveld, Netherlands. So just to see if your system is working well and understand where are you joining us from, we would like to put first of all, let us know where are you joining us from. You can see us pop up on your screen, select one, and I can also share the result soon. Oh, so we see Americas is leading. Then we have Asia, Europe, 31. Oh, interesting. All right, so 36% Americas, 29% Asia's, and oh, okay, still number of votes are counting. All right, so I see 33% Americas, 27% Asia, and 40% Europe. Such a diverse crowd. So for my expert, I'm sure there will be a lot of questions from this geography. All right. So without further ado, I would like to invite on the stage our first expert and the Brine Innovation Manager, Christos, and he's going to share his insights and the knowledge about zero liquid discharge and how you can turn waste into wealth with the ZLD approach. Christos, over to you.
Thank you very much, Amol. So hello, everybody, and greetings from Amsterdam. First, I would like to thank Amol and his colleagues to invite me to this very interesting webinar. Yeah, and I would like to put a disclaimer that I'm here representing myself as a high-end specialist, and I'm not here to represent the company that currently employs me. So, with that out of the way, in the next 20 minutes, we will go through the challenges today that are posed by high salinity wastewaters, and we're going to explore the innovative methods for their treatment and recovery. We will discuss the environmental impact of these wastewaters, examine the composition, and outline the steps that are involved in the treatment process. By the end of this presentation, I hope that you will have gained a comprehensive understanding of brine management and its significance in achieving sustainable environmental practices. So, Amol, next slide. Okay, great, thank you. So, high salinity industrial wastewaters, what is it? It's a growing concern in today's industrial landscape, and they result from a myriad of processes and practices. One of the primary reasons behind the rising salinity is the increasing demand for fresh water, leading to the utilization of unconventional water sources. Additionally, industrial processes have become more intricate and resource intensive, requiring larger quantities of water. Consequently, the concentration of salts and minerals in the discharged wastewater escalates. Furthermore, the rampant use of chemical agents in various industries, such as mining, textile, petrochemicals, and others, significantly contribute to elevated salinity levels, enhancing the wastewater complexity and posing a significant puzzle for us as water professionals to solve. We need to provide an innovative solution that not only manages the escalating salinity from one point, but also transform these challenges into opportunities, offering sustainable and economically viable pathways for industries to address their wastewater concerns effectively. Next slide, please. Next slide.
Yes, so we will quickly understand if our audience has knowledge about zero liquid discharge, where are they from, what kind of background they have. And the question is, have you encountered zero liquid discharge systems or similar technologies in industrial settings before? So number one is, yes, I have implemented or work. Yes, I'm familiar, but indirectly, not work directly. Or no, I have not encountered ZLD system before. This is something new for me. And last is not sure. And Christos, the good news is almost 50% of our audience have implemented or worked with ZLD in the past. So
okay, great.
They know
so
this subject.
It means there are still projects for me to work on, no?
Yes. Okay, then I move to next
Okay.
slide, and then we continue.
Okay, so next slide, if possible. Okay, to the composition of industrial brines. So we have to understand as professionals that industrial brines are complex, highly variable, and comprise of various contaminants derived from diverse industrial processes. Common contaminants include heavy metals originating from mining and metallurgical activities, or organic pollutants such as solvents and pesticides from chemical and agricultural industries. Salts and minerals, fundamental components, are intensified due to water-intensive processes in sectors like food processing or power generation. The necessity of a detailed analysis becomes paramount when addressing wastewater treatments on a case-by-case basis. Each industrial sector introduces unique contaminants, demanding a tailored approach. This personalized strategy ensures not only effective treatments of the said effluent streams, but also the responsible disposal of contaminants, allowing for a versatile and adaptive solution for a wide array of industrial challenges. So next slide, please. Okay, so there are always some very fundamental steps to treating brine streams. And the process is a carefully orchestrated series of sequential steps, each crucial on its own right. And first, you have, of course, pretreatment. The process begins with a thorough pretreatment step, where industrial wastewater undergoes screening and chemical adjustment to remove impurities. This step sets the foundation for efficient extraction of the contaminants by ensuring that the wastewater is optimized for further processing. Then we have concentration, and this is the heart and most crucial operation of the process scheme. The chosen configuration will set the OPEX parameters, which will influence your ROI, return on investments, and make or break the project. Then we have crystallization and separation. Controlled crystallization is very vital, as it separates salts and minerals from the remaining liquid, and it has to be designed in such a way that minimizes the unusable salt side streams, because we also have those, and maximizes the amount of desirable commercial products. Then, of course, we have drying and packaging. The extracted salts and minerals are dried to remove any remaining moisture, enhancing the purity. These dried materials are then packaged and ready for distribution to end markets. And then we, of course, you have environmental management. Concurrently, the treated water, now significantly reduced in salinity, undergoes rigorous testing to ensure it meets the local environmental standards. This water can be responsibly released into water bodies or utilized for non-potable purposes, minimizing environmental impact. Now, this holistic approach not only transforms industrial waste into viable commodities, but also sets a new standard for sustainable wastewater treatment practices. And into the next slide, please. Okay, great. So let's talk a bit about the recovery processes that we have in our toolbox in order to recover the desired salts, minerals, and other products. At the later stages of brine mining lies sophisticated processes, including chemical precipitation, crystallization, and scavenger resins, employed in the final steps to extract valuable salts with minerals with precision. First, we have chemical precipitation. Through chemical reactions, impurities bind together and settle at the bottom, leaving behind a purified solution. Chemical precipitation is particularly effective in removing heavy metals and unwanted contaminants, ensuring the extracted salts and minerals therein meet high quality standards. Then we have the thermal processes step, which is crystallization. And controlled crystallization is a key technique where the concentrated solution is cooled or evaporated under precise conditions. As the solution cools, crystals of salts and minerals are formed. These crystals are then separated from the remaining solution. Crystallization is essential for producing high purity salts that meet the ever higher specifications of today's end clients. And this is why, as KLAREN will explain a bit afterwards, that we need optimized solutions for the operation of these systems. Lastly, we have the scavenger resins, and scavenger resins are highly specialized materials designed to recover especially precious elements that are essential for cutting-edge technologies and are a lucrative resource. These advanced techniques ensure that brine mining achieves not only high efficiency, but also exceptional selectivity, enabling the extraction of salts and minerals at a level of purity that meets the stringent demands of modern industries and opens doors to a myriad of commercial applications. So next slides. And now it's the topic that we all dread when we are designing the business case for its project. It's the project OpEx. In today's landscape of environmental responsibility and economic efficiency, the treatment of brine effluents demands careful consideration of cost-effective methods and optimized operational solutions. By prioritizing cost-effectiveness, industries not only mitigate their environmental impact, but also ensure sustainable business practices. Efficient treatment methods significantly reduce operational expenses, making it financially viable for industries to manage their brine effluents responsibly. Through the adoption of optimized operational solutions, such as Zero Liquid Discharge systems, industries can effectively minimize waste and extract valuable resources from brine effluents. These solutions not only reduce the burden on freshwater resources, but also contribute to the circular economy by recovering valuable salts and minerals. Furthermore, cost-effective approaches enhance the competitiveness of industries in the global market. By minimizing operational costs associated with brine treatment, companies can allocate resources to other areas of innovation and growth, fostering long-term sustainability and resilience. So I think this is the end of the presentation, and now I would like to welcome any questions or discussions on this topic. Sorry, I do have the conclusion keys. Sorry for that, the conclusion slide. And the first point that we need to get is, of course, that increased industrialization leads to higher salinity wastewaters, and more complex cases for us to solve. Within these brine streams, second point, there are a lot of contaminants that have high value as high purity products to potential off-takers. From pre-treatments to the recovery of the said high purity products, we have identified in this presentation all the necessary steps that need to be taken in order to extract those products efficiently. We have stated that the OpEx is the key parameter that makes or breaks the business case of every ZLD or brine mining project, and then that promoting such processes as ion separation, softening, membrane concentration, and internal recycling can provide us with viable ZLD solutions. So thank you everybody for hearing me out. And I'm more than happy to answer to any questions that you might have.
Yes, Christos, thank you so much for interesting glimpse of zero liquid discharge system and solution. I'm sure our audience.
On time, no?
Yes, you're well before time. You're still a couple of minutes, but let's utilize this for some interesting questions.
More time for questions, yeah?
Yes, more time for questions because the engagement is important. And as we see that almost half of them are from Americas and then Europe and Asia, I'm sure some of the interesting questions I have. But before that, you asked me to also put this poll, especially to understand what our audience think about brine effluent treatment. And I'm going to launch it and then we move to questions immediately. And in the meantime, audience, feel free to ask your questions in the chat box. So the question is, what aspects of brine effluent treatment do you believe possess the greatest challenge? Is it cost effectiveness, environmental impact, operational efficiency, technological complexity, or regulatory compliance? So I see the cost effectiveness is leading. Okay, 50% says cost effectiveness, and then it comes to operational efficiency. 54% is cost effectiveness already leading. Okay, 47%. All right. So, Chris, is there any surprise that 47% of our audience says the biggest challenge is the cost effectiveness? Would you like to shed some light on this poll?
Well, it's pretty clear that you need to have a good value for your bag when you're paying, when you're designing such kind of processes. And essentially, we have gone through again that the cost is that when most of the clients hear about the relative costs, this is what pushes them away from similar projects. So in most of my career, I have dealt with small to medium clients that would like to do ZLD. And of course, it is difficult to, with such relative costs, to convince them to push the button for the project. Even bigger clients are risk aversive, yeah, due to the costs. And of course, it always comes down to the fact that you have to understand also the relative risks, yeah. And this is why I hope that me and other relative specialists out in the market, by conveying the message, we can explain to the people that right now, as it stands, there are commercial methods that we can get to ZLD cost effectively.
Interesting. Thanks. So let's move to some questions. And as I said, audience can still ask some questions. We can have, yeah, another 5-6 minutes to, dig deep into this area and help our audience to understand a little bit more. The one question, interesting question I found here is, because all of us, we know that Asia usually is leading when it comes to ZLD, and there is a question, what are your views of ZLD in the Western world?
So, yeah, we still are way behind from Southeast Asia mostly, and this is due to the fact that we don't have the regulatory push. Yeah, if essentially in the Western world, you don't have a knife on your throat, you're not gonna go ahead and sign such an expensive project. But the thing is that I think also from our side as water professionals, we haven't clarified it to the market what potentially such a project would mean to end clients through water reuse and potentially also the creation of new revenue streams from resource recovery. Yeah, and how they could get potential funding for all of this. Yeah, through all the very nice buzzwords that we can couple with such a project, and they would go very well with the ESG metrics. So that's my answers for this question.
So we need to wait and watch what's happening in the next years.
I think that eventually the water stress is going to go so high that we will run essentially like panic chickens in order to get these projects going in the Western world, when India and China, for example, have done it 10 years ago.
Okay.
So eventually we will get there. It's a matter of time, but the thing is that, and as I had explained this also in my presentations in Aquatech Amsterdam, the industry needs to be proactive. Yeah, the Western industry needs to be proactive, and we need to educate the public sector and the private sector as to the conditions that we are right now with water resources and how we can help alleviate this stress.
Yeah,
and also offer nice buzzwords as decarbonization through resource recovery, etc., etc.
Okay, interesting. Thank you. There's another interesting question, and of course, it has some connection with our technology as well. And as all of us know, there are development in terms of type of membranes and their capabilities and everything. And you did mention something about the concentration areas as well. So the question one of the audience has put is, what is the future of ZLD when it comes to thermal operations?
So the future of thermal operations in ZLD is pretty solid for the foreseeable future. Yeah, of course, we have tried to replace thermal systems as much as possible with membranes, and we have achieved it at least up to 250 grams per liter, more or less, with the necessary steps and configurations. But the wide application worldwide of such membrane systems is yet 5 to 8 years ahead of time, and is ahead, sorry. And I personally don't see thermal systems going anywhere for the next 15, 20 years. So any options that we have to optimize their operations are crucial.
Okay, so we have enough work for next 15, 20 years and help industries to solve
minimum
thermal evaporators problems. Right, Marco will explain more. And yeah, there are a couple of other questions, but we will see depending on how much time we have after Marco's session. But maybe last thing, because I see almost 30 to 35% audience, they did not have any relation with ZLD, and I had exactly similar a couple of years back when I started my career in Taprogge, and I was looking everywhere where to learn about ZLD, what to learn, and what resources should I look at. Do you have any tip that what is the starting point that start from there and then slowly build up?
So I had exactly the same problem back in 2018, more or less, when I started to work more seriously on the topic. And this is why I wrote my own book on the topic for my previous employer. And I would suggest that you look out for ZLD Fundamentals PDF on in Google, or you can go to my LinkedIn profile and check the relative booklets that I have included over there. Yeah, ZLD Fundamentals and Design. It's one of the very few books out there that describe the whole process from A to Z, and it's completely free online.
Okay, perfect. So in one of the slides, they also link of your LinkedIn profile, and I hope attendees who have downloaded our presentation, they would find you, and they would also find a starting point. That's very important. And the great example that if you can't find a solution, be a solution. I like that approach, Christos. Thank you so much.
Thank you very much.
With this, I think I can give you a break for a few minutes, and then we can get Marco on the floor. Welcome, Marco. So after learning a little bit basics about ZLD and those thought-provoking questions, the time is to understand when it comes to thermal evaporation, what are the limitations, what are the issues, and what we as a Taprogge GmbH with our innovative self-cleaning evaporator help industries to even achieve better operations in their plants. So Marco, the floor is yours. And yeah, we are happy to hear more from your side as well.
Yeah, thank you, Amol. Thank you also, Christos, for your clear explanation about wastewater management, about brine management, about taking the opportunity to go even back to resources. Yeah, what we also have learned from you, but also from the market, is that, of course, membranes are playing a more and more important role in this brine management, in this wastewater treatment. And I think that's also a very good thing, because treating water, concentrating water, and as I will explain more, evaporating water to reduce the volume at the end is quite energy intensive. And the more and more we can do with membranes, the better it will be. But what we also have learned from the market and from talking to experts is that there are limitations in membranes. And I'm not a membrane expert. I will also not pretend to be one. But it all has to do with the type of membranes, the required lifetime, the composition, the presence of organics, operating conditions. So what we see when people approach us for an evaporation solution, that we get a feed stream that contains around 5 to 10% weight of solids. And that maybe not sound much. Maybe that's also still a little bit away from the maximum that membranes can achieve. But we should realize that at that moment already the volume of the wastewater stream is reduced by a factor of 5 to 10. So already 80% or maybe even 90% of the water is treated with very efficient solutions like membranes. But still, then you're not to ZLD. So there's still a requirement to further reduce the volume and to concentrate further up to saturation or even crystallization. And this is where, in fact, the thermal systems, like mentioned already before, evaporation comes into play and still will play an important role. So today I will discuss more about evaporation and also about the energy efficiency of evaporation, because you can do quite a lot to improve this. And I will then focus more on the role that fouling plays in this energy efficiency, because it does, both in multi-effect evaporators, but also in MVR systems. So fouling plays an important role, and if we can solve that by our KLAREN Technology self-cleaning heat exchanger, of course, this can give a big contribution to the performance. We can go to the next slide. Just to give you an idea, there are more ways more thermal ways, more evaporation ways that can be used to reduce the volume or to let's say take water out of the brine stream. Maybe the most old-fashioned way would be to use a solar pond, meaning that you have a shallow, big area in which the brine is put, and you simply make use of the solar energy to evaporate the water, and over time only the salt will be left. and the salt can then be harvested and reused or put in a solid waste field. Of course, not wanted, but still used quite sometimes. Another way is a system which is called humidification dehumidification. Maybe not so widely known, but this is a system that also one of our sister companies is offering, the Zero Water technology within Taprogge. And this makes use of the difference, in fact, about the water quantity that hot air can absorb compared to cold air. So in this system, the brine stream is heated with an additional heat source, and this hot brine is then sprayed over a tower, in which in counterflow there is an airstream, and this airstream will heat up, and at the same moment can absorb more water than what it used to. And after this heating and absorbing the water, the airstream is then put over let's say the right part of this system, the condenser system, where it cools down again. It will then have to release its water content, so condenses, and you will have distillate coming out. This condensing section is arranged such that the incoming brine is in fact preheated before it enters into the heater, and then the cycle is round again. So you make use of and that air can contain more water when it's hot. On the left side, we see two systems which with evaporation by a medium of steam or by a compressor. When you talk about steam, it would be a multi-effect evaporator plant. I will discuss that in detail, but it means that you use a heating medium, in fact, to evaporate the water. And then in a sequence of effects, you can make this more efficient, but more about that later. The second alternative is not to use a steam, but to use a compressor, where in fact we use electrical energy to evaporate the water, but at the same time also condense it. The options on the left, I will discuss them in more detail right now. So we can also go to the next slides. If you evaporate water, and in fact this is also in our internal training for new engineers, you can easily calculate that if you want to evaporate 1 cube of water, you need around 630 kilowatt thermal energy to evaporate these 1,000 liters. So that's a huge amount of energy, and this energy goes into the vapor chain or into the phase change between liquid and vapor. And this is exactly where you also have to look for improving energy efficiency. Because one thing that you can do is, once you have evaporated the water, use this same water to condense again, and then at the same time evaporate the second batch of water. So that's in fact the cascade of evaporation effects in series, where you make use of a reducing vapor pressure such that, let's say it in sequence, in series, you can use the vapor to condense, evaporate again, condense, and that then in X effects. And then you can improve your, what they also sometimes call the steam economy, with already a huge factor. So what they then call how much kg of water can you evaporate with 1 kg of steam, and you can reach the numbers of 4 to 5. So then a number of 630 would already be reduced to something like 120, 130 kilowatt thermic energy that you require. And I would like then to also ask specific attention to the use of a TVR, because with a TVR, in fact, we can reduce the amount of vapor that at the end needs to be destroyed in the condenser. And a TVR is in fact a device which entrains vapor from one of the effects, then combines it with the the motive steam, generating a secondary vapor steam, which still can be used to use as meeting helium. But with the main effect is that you reduce the amount of vapor that has to go to your condenser. So together, multi-effects and TVR can in fact improve your energy efficiency of these type of systems. The next slide will then show you that another option is to go to mechanical vapor recompression, because I already said, you have to look at where does your vapor stream go, because your vapor stream is the main loss, energy loss that you have in your system. Well, with mechanical vapor recompression, in fact, you use all the vapor, you increase the pressure, and by increasing the pressure, you increase the temperature, such that you can use it again as your heating medium in the heat exchanger of this evaporator. And because you condense all the vapor, in fact, there's no vapor loss stream anymore. So all the energy that you have put in the phase change is in fact recovered. And this is how you can reduce your energy compared to MEE, again, with a factor 2 or more. So that gives you a substantial saving in energy consumption. But there is an important trade-off in the design of MVRs, and that's what you can see in the next slides. And this has to do with the design of the heat exchanger. As I said, that you use the compressor, in fact, to generate an additional temperature. And this temperature you get by a certain compression ratio. And the higher the compression ratio, in fact, the more temperature that you get. And this also means that you can design your heat exchanger smaller. So if we take case A, in fact, so this gives a compression ratio of 1.7, giving a temperature increase of 13 degrees. At the end, you would get to a heat exchanger design of or almost 60 square meter. But when I then reduce my compression ratio, I also get a lower temperature, and you see my heat exchange surface, in fact, goes to 270% of this original heat exchange surface in case A. So that's a substantial increase, meaning more investment. But on the other hand, if we then look at the energy consumption, if I have the lower compression ratio, meaning more area, you see how much my compressor or how much lower the energy is, the electrical energy is that the compressor will use. So this is only 62% of the original 42 kilowatt. So with MVR, it's very important that you, let's say, have to make a selection between going for some more investment but lower energy use, or vice versa. So this is a very important thing to keep in mind with MVR systems. I think we can go to the next slide, but I think this is time for a poll.
Yes, Marco, that's correct. I think, as you mentioned, it's important to understand if our audience has also knowledge about MVR and what do they think. So the question will be launching in a couple of seconds. Question to audience is, how do you prioritize OPEX versus CAPEX in the context of designing MVR system in an efficient heat exchanger to save energy? So you can vote either OPEX is important to me, OPEX and CAPEX both are equally important, or only CAPEX, or it doesn't really matter. I see that most of the audience, they think both OPEX and CAPEX are equally important. And some of them, they 8%, 7%, they think, yeah, either OPEX or CAPEX is more important to them. So, but it's clearly visible, Marco, that OPEX and CAPEX are equally important to them. Would you like to shed some light on this poll already?
Yeah, well, what I can say is we recognize this because there was always, of course, discussion about can we reduce the investment for an MVR and MEE plant, but at the same time, the energy efficiency should, of course, also be good. So yeah, it's clear that it's always, let's say, seeing if you can improve on both sides. And that's also maybe a nice bridge to the next slides.
Yeah, okay. So there are some questions about MVR, but we will go back to it towards the end, and I'll move to next slide.
Yeah, let's do that at the end. Because fouling is something which happens in the heat exchanger, not always, but in many cases it does. So where already on the heat exchange surface you have crystallization of one of the salts, of one of the impurities, and in fact this in the basics reduces the heat transfer. And of course, if you have this, you also need to clean it, you need to look at the design. But today is about energy efficiency, so we can go to the next slide, where I will say more about how this influences, in fact, your evaporation performance. Because for a multi-effect evaporator, fouling predominantly reduces capacity. That's really the biggest issue. But in the meantime, it's also a little bit of a silent killer for your energy efficiency. And this specifically holds for ME with the TVR. And what is the reason for this? Well, I can explain if you would like to know more later in detail, but it has to do with that if fouling occurs, the pressures in your system changes. And when the pressure in the evaporation system changes, in fact, it influences how much vapor is entrained by the TVR. And in fact, it reduces this entrainment. And because it reduces this entrainment, in fact, the net effect is that more vapor will go to the condenser, and more vapor, more latent energy is destroyed. So fouling does influence the energy efficiency of an ME. 5 years ago, I thought it wouldn't, but I'm now absolutely sure it does. And we also get that back from our customers. But in an MVR, it's even more direct. Because if fouling reduces your heat transfer, that means that your blower will need to do more compression ratio to maintain the same capacity. That means the delta T over the heat exchanger has to increase. And this automatically one-on-one or increases the compression ratio of your compressor. And as we have seen in the previous slide, if this compression ratio goes up, your electrical consumption goes up. So there's a direct relation between fouling and the MVR, the performance of the MVR in terms of the use of electrical energy. So fouling has a significant influence on energy efficiency, but also in performance in general of your thermal system, because it also influences your capacity and your uptime. So what is our target? The target with the KLAREN technology, in fact, is to avoid this fouling, to make sure that the heat exchanger remains clean. So what you see is that where we start with clients that have a problem, which have a picture at the top left. So dirty tubes, some of the tubes clogged, is that after a change, in fact, when we open the heat exchanger, and that's in fact when the picture was taken, you still see shiny tubes. And the shiny tubes have an optimal heat transfer coefficient. So if you talk about evaporation capacity, we go from a straight declining line in with the blue dots, still in the previous slide, till the in fact the constant line with the red circles, where there's a constant evaporation capacity. And how do we do this? How do we achieve this? Well, we have given webinars where we went in detail about how our technology works. So I will just try to describe in short. I'm not so good in that. But in principle, what we do is we apply a fluidized bed of cleaning particles at the inside of the tubes of a vertical shell and tube heat exchanger. And this shell and tube heat exchanger is then in the heart of this evaporator. So we add those cleaning particles at the bottom of the shell and tube heat exchanger. They are then taken upward by the flow. Inside the tube, they have this chaotic manner of movement, and in this chaotic movement, they impact the tube wall. And it's these very light impacts that in fact give the cleaning mechanism, give the scoring action that cleans continuously. So the system is in continuous use, cleans the tubes, making sure that the heat transfer performance remains optimal. After that, they have passed through the heat exchanger. We separate the particles in a particle separator, and then via a downcomer, they are fed back to the inlet. So we have a continuous recirculation of cleaning particles, which is an integral part of the evaporator system. Yeah, so that's the core of what the KLAREN technology, of what the self-cleaning technology does. If there's more questions on the specifics, I can answer them later in the question session. When we use this technology, in fact, we can show this via this case study. Quite a recent project we did. I think it's around 1.5 years. No, it's almost 2 years ago that we did this for a bigger company in India. This was a 5-effect evaporator plant where at the end they recovered sodium sulfate salt from this mother liquor from a plant. So a perfect example of a ZLD system. So concentrating up to the moment of crystallization, and at the moment that the crystals were formed and had the appropriate concentration, in fact, they were taken out by a centrifuge. This plant experienced significant fouling in the first and second effect of the plant. Heat transfer, when we did the analysis, reduced with maybe almost 50 to 60%. And this was only by a thin layer, or only 1 to 2 millimeters. So even a thin layer can already ruin your heat transfer, let's say, with a great extent. So what we have done is that we change this 5 effect, in fact, to a 5 effect, but then with the first effect having self-cleaning, because this is the effect where they had the most of the fouling issues. So it was really temperature driven by the fresh steam. We can go to the next slide. So we have changed. We have changed this into our self-cleaning system. So that means we have to change the flow. We had to add some additional parts like an inlet channel, distribution system, particle separator, downcomer, the control flow. So some mechanical changes we needed to do. And afterwards that we did the commissioning, and we found that indeed we had improved the steam economy, so like explained before, but also the total throughput of the whole system had increased with 10%. In fact, it was even a little more. So we removed the bottleneck, we improved the steam efficiency, and at the end we got a very nice recommendation letter by the customer. In the next slide, before I get to rounding up this presentation, you see some of the pictures of recent installations that we have done. So going from Multi Effect Evaporators to also the first MVRs that we have built and which are currently in operation. We can go to the next slide. The next slide is that we can answer some questions, but maybe just to say some last words. So fouling really has an impact on the performance, on the thermal efficiency of your evaporation or of your thermal systems. And we know if there is fouling and you have this fouling issue, that we can provide a solution. Thereby, let's say, improving or reducing the amount of energy that you need for treating these brines. The end, that just improves the business case, which at the end is good for the financial items, but also is good for the environment because less primary energy is needed.
Yes. Thank you so much, Marco. I saw a couple of questions popping up. And let's have, I think we have 5 minutes overall. So let's have a couple of questions now. And those attendees, I saw two attendees wanted to discuss this subject offline, so we can send them an email and invite for additional discussions. So for others, if you could not answer today, we will ensure that those questions are answered through email or one-on-one meeting. Somebody asked again, can you explain a little bit more about how fouling influences the energy efficiency of MEE?
Yeah, for sure I can. Maybe you can go back to that slide that shows the TVR. In fact, in the first years that I joined KLAREN, I was also of the opinion that for an ME, let's say fouling should not have any effect on the steam efficiency. But later, more and more we got customers say, yeah, but with fouling, our efficiency goes down. So at the end, doing some further design studies, we found that this has to do with the TVR. Because if you put a black box around an evaporator and you make an energy balance, in fact, the stream where you lose your energy is the vapor stream that goes to the condenser for an ME. And as you can imagine that at the moment that the entrainment, so the amount of vapor that is sucked in by the TVR goes up, less energy goes to the condenser, so that's good. But what happens with fouling is that the pressures change, and in fact that you get less entrainment. So less entrainment means more vapor that goes to the condenser, and more vapor to the condenser means in fact a lower energy efficiency. If you look at the total energy efficiency of the plant, that's around 5 to 10%. But if you calculate the numbers over a year, that it has a really substantial benefit in terms of money, but also, of course, in terms of energy and emissions.
Yeah, thank you so much, Marco. I'm sure some of the attendees would contact us and understand more about how we calculate return on investment and how we can improve it further. There's another interesting question. Somebody's asking, is there a self-cleaning evaporator behind you?
Well, that question came from you, I guess. No, I'm sitting in front of our lab, or at least you can look into our lab. So it's on the back side. Indeed, we have a demo unit for our self-cleaning heat exchanger, in which we optimize some of the parameters and also train our engineers such that they know how to operate it, but also know how to influence the performance. So yes, I'm in front of a self-cleaning heat exchanger.
Yeah, let's have last two quick questions. Then I would like to invite Christos on the stage, and then we conclude. What's the approximate capex increase with the self-cleaning evaporator?
Yeah, well, it's always a tricky question. We have to be very clear about is that we do not have a cheap technology. Yeah, if there's hardly any fouling or you need to clean once per year, I think there will not be a good business case, or the amortization will not be right. But if you really clean once per month and you really see a decrease in capacity, yes, there will be a business case. And the capex involved will really depend on how big your system is. Telling a number would always mean that I'm wrong. So if someone has a specific case in mind, we can always give a ballpark figure, but that has to be adapted to how big the installation is.
Okay, thanks. Now, since we have last 1 minute, a couple of questions. If some of the attendees would like to understand about our current project, so it's available on the website. There are some standard questions that we always receive about the effect of cleaning balls on the tube. So those are also available, and we can answer some of the question directly to the attendee. I would like to invite quickly Christos on the stage. We also thought to go through those LinkedIn polls, but I think time is not permitted for now, but attendees would get this presentation. And just to highlight that this is something that we tried in last few days and asked attendees what they think about the specific subject, and there are polls So they would also get benefits out of it. And I would like to thank again both of you for your valuable time and yeah, interesting discussion. Time is never enough for discussing this kind of subject, and I'm sure sooner or later we will again have one more webinar and go a little bit deep. If you want to add quickly in 30 seconds, just feel free. And with this, I would also like to thank all the attendees. This handout is available with our LinkedIn links, and then our website is highly interactive for additional brochures, downloads, and all webinars. And yeah, we are exhibiting all over the world and showcasing different products. So feel free to connect with us over there, or write us at sales@Taprogge stand. And yeah, so far this is what I would like to highlight for today. And I'm sure some of them really wanted to discuss offline, so I have to connect with at least 3 attendees. What exactly are their questions and so on. So Marco and Christos, if you have something to add, just let me know.
Not particularly, but I would like to thank you, Amol, personally for all the good work and efforts you put into organizing this webinar and all the very interesting posts and polls during the last days. Yeah, that was an excellent approach as far as I'm concerned. And thank you again for inviting me to this very interesting webinar.
Thank you so much, Christos. I appreciate it. And Marco?
Yeah, well, I think what I would like to say also, Christos, thank you very much to give this very important introduction into the subject, and also to showcase that it's not only about, let's say, reducing the water volume, but also about creating a very valuable resource. Because at the end, I think when it comes to sustainability, we have to really look at closing the cycles. And that means also reusing everything which was in the water to start with. So thanks for this very great part of your presentation.
Much appreciated.
Yes. So let's do the good job and contribute to the greener future and sustainability. Thank you again for all of you attending and spending time with us. We will be in touch. Bye-bye.
Bye-bye.
Take care, everyone.